And this would be 22.2 repeating microcoulombs. When I go into series, it doesn't change the amount of charge, so if let's come up with some consistency here. So if I know I've got 22.2 microcoulombs sitting on these plates right here, basically I just separated them and stuck something in between. So this one would still be 22.2 microcoulombs. This one would be negative 22.2 microcoulombs. And so these plates would be the opposite, because they're capacitors, and so this would be positive 22.2, and this would be negative 22.2. I can now find the voltage across it, because by voltage is charge divided by capacitance. I know the capacitance is 4, my charge is 22.2, divide, and I have voltage. Which is roughly 5.5 volts. So I made this 10 volts here. So if I gain 10 going across there, I'm going to lose 5.5 going across this. What else do I need to lose when I go across this? Well, whatever 10 minus 5.5 is. 4.5-ish. So now I know the potential drop across here. And it doesn't matter which path I take, I'm going to be losing roughly 4.5 volts either way. And now we can find the charge on those plates. It was a quick sketch of run through there, but I see some furrowed brows and some nonchalant looks.
Yeah.
Any more specific questions on this, or I can go through that more slowly? It's not as directly related to the textbook. I don't think there's a question like this in this textbook. But it might be a fun little problem for a test.
I blame Wesley if that's the
It feels like it'd be more appropriate for the next test instead of the second test instead of the first one. Other questions? All right, I say let's do this quiz and be done with it. I don't want the world to see how I erase the board.